Okay, guys, right now I'm going to explain the area bound by a curve and a line or by two curves. So this one is about finding the area bound by a curve and a line combining, or by curve and curve or two curves. Okay. Before, you already know how to find or calculate the area under the curve, and now we try to find the further is when the area is bound by two curves or combining curves with line. So what we are going to do, so let's see. uh, this one, the example 9.14, you see this example. The shaded region A here is bound by the blue curve and the red curve, right? So the blue, it indicates as y equals fx, and the red curve is y equals gx, right? So these two functions form this area, the blue area A, and then we are going to find it, the area of A. And how to find it? So this the key point or the formula to find this area bound by these two curves. So the area, the indefinite integration of fx with the limit from A. Look here, the A is intersection of these two curves, and B also. Fx dx subtracted by integration, definite integration of gx dx with limits A to B. Okay, since the limit are the same, right, the intersection A to B, so we just simplify as one formula. A equals the integration of fx subtracted by gx in the brackets, respect to x, in the limit from A to B, like this. So just simplify the formula. Suppose we have this two curves and this line. So this curve is defined as x minus x squared plus 8x minus 5, this curve. And then with this line, y equals x plus 1. So we need to find this area, okay, the blue area. What to do, we can apply this directly. So we just simply subtracted minus x squared plus x, 8x minus 5 by x plus 1. So here like this, we got minus x squared plus 7x, right? Minus 6. So we subtract 8x by x, and then we subtract minus 5 by 1. So it will be minus 6. Okay, after that, we perform the definite integration as usual. So we dv integrate it one by one like this. So minus x squared, it will be minus x cubed over 3 plus 7x, we integrate, it will be 7x squared over 2, and then minus x will be 6x, and then the limit from 1 to 6. Firstly, we need to substitute x by 6 first, right? Here we substitute by 6, and then subtracted by, we substitute x by 1, and then we subtracted it. Okay, we subtract this value with this value. Remember, you should substitute the highest value first. Okay, 6, and then subtracted by 1 for substituting x. All right, so the answer, it will be 25 over 6 units square. So this is how we can apply this formula. Okay, nah, actually, what is the relation between this area bound by curve and line, or by two curves, by with the previous subtopics, area under curves? Actually, it has no difference. I will show you why. All right, so you know this one, right? This is area under curve, and to find this area actually, wait, the draw with red. So we just transform this into definite integration, right? From, look, this one is from 2 until 5, so just 2 until 5, and then y equals x squared, the curve. So just write x squared dx like this, right? And then to solve it, we just integrated x squared, so it will be x cubed over 3. This one should be 5 2, right? So we substitute 5 first, so 5 cubed over 3, right? Subtracted by 2 cube over 3, right? Equals 125 over 3 minus 8 over 3, or 100, how many? 117, right? Over 3. So this is the area, I'm sorry. So the area, it will be 117 over 3 unit square, like this, right? Now, the relation between this with area bound by two curve or curve in line, as you can see here, this area also it's bound by this curve x square and this straight line or the x-axis, right? You know that x-axis is equal to y equals 0, right? Now, we can do the same technique in bound by two curve or curve with line. So actually this area it's come from bounded by this curve and x-axis, or y equals x squared and y equals 0. If we perform like the area, it will be the area of 2 to 5 of x squared dx, right? Subtracted by the area of from 2 to 5 of y equals 0. Y equals 0 is 0 dx, like this before, right? So this one, it will be x squared dx, sorry, this one here, minus, you know that 0, if you integrate 0, so it will be 0, that way is 0. Now that's why this area under a curve, okay, you just only need to find only this value, because this bounded, the second bounded is y equals 0. If you integrate it, it will be 0. All right, that's why it's just keep like this. A equals only this area, that's why it's area under curve. Similarly with before, yeah, with before, this one is bound by this blue line, bound by the red line. That's why fx subtracted by gx, like this. If this one is fx and this one is gx, is also fx gx. But for gx here is already 0, that's why it's only fx. Okay, so this is the idea. So actually, area bounded by a line and curve or by two curves is actually area under a curve, or area under a curve is also area bound by a line and a curve or by two curves. So it's the same actually. Okay, so this is the idea, yeah. So it's basically the same. So let's see the example, the next example, I mean. Not this one, this one first. Okay. All right, now the diagram show the curve y equals x squared minus 6x minus 2 and the line, this one, y equals to x minus 9, which intersects when x equals 1, this one, and then x equals 7, that one. So you have to find it. So firstly, nah, to find this one, according to this formula or rule, the upper one subtracted by the under one, okay, or the yeah, upper and lower, the lower one, okay. So it should be the upper one subtracted by the lower one. So the straight line subtracted by the curve. So look here, the straight line is 2x minus 9 subtracted by the curve x squared minus 6x minus 2 dx. And then after you subtract it, it will be minus x squared plus 8x minus 7. And then you can integrate it by using definite integration. And then you got 36 units square. Okay. And another example, how about this? Okay. Find the area of the region bound the curve y equals 5 plus 6x minus x squared, that one. The line x equals 4 and the line y equals 5. So we have 3 here, but actually it's not 3 since x equals 4 is the limit, and another limit, it should be x equals 0, right? So you can simply write this is the first function. Let's say this is fx and this line is gx, and this is the limit. The limit is from 0 to 4, right? This, okay, this one, the limit, okay. Okay, so the limit is this, and this is the two function fx and gx. And how to solve it? First, by using the formula. So since the limit are the same, so we can directly, yeah, so from 0 to 4, the upper one, it will be the curve. So 5 plus 6x minus x squared minus the gx here is 5, so it's 5. The lower is y equals 5. Y equals 5 is this here, y equals 5. Okay, dx. Okay, so this one will be, if we simplify, it will be 5, and it's not 5. 5 minus 5, it will be 0. 0, right? So it remains only 6x minus x squared dx. Okay, and then if we, this is definite integration, right? So if we calculate, we integrate, so it's 6x squared over 2 minus x cubed over 3. Yes, 0. Okay, and then this one, it should be 3x x squared, like this. Firstly 4, so 3 times 4 squared minus 4 cubed over 3, right? Subtracted by 0 minus 0. Okay, so here will be only that one. So it's 3 times 16 minus 64 over 3, right? How many? 3 times 6, or if we multiply by 6 by 3, uh, over 3, so 9, 16, 16 times 9, how many? 4, 14, 144 minus 64, so it will be 80, right? So 80 over 3. Okay, so the area is 80 over 3 unit square. Okay, so this is how we can find it. Let's check the answer from this. Actually, I take it from this website. Show answer. Okay, 26 times 3 plus 2 is 18. 1. 78 plus 2, yes, 80 over is true, yeah, 80 over 3, that is true, the same. Okay, the next example. Now, how about if we don't have the the graph or the figure like this? Okay, how to find it? Okay, let's find out. Sketch the following curves and line and find the area enclosed between their graphs. Okay, even though we need to draw or sketch this one, but if you can imagine, so you no need to sketch. But here I need to show how to sketch because it's very important to determine which one is upper and which one is the lower, right? So if it's sketch, it will be uh, x, y. This one is 6, so it will be okay. So it will be y equals 6, right? And then y equals x squared plus 3x squared. It should be is like this, yeah. It's like curve upward, right? And the the vertex is 0, 0.0, but it's minus 3. It means we shift to the down, yeah, to the down. So it will be, if 6 is here, so minus 3 should be here. So it should be like this. Okay, so the vertex should be here. Okay, I'm sorry, my drawing is not good here. So we need to find this area. Okay, all right, but here we can determine that the upper y equals 6 and the lower is this, yeah, x squared minus 3, so doesn't matter. So the area will be, how about the limit here? We don't find the limit yet. Yes, of course, this intersection, choose 2 in how many x, and that one also in which x. We don't find it. And how to find it? You know that y equals x squared minus 3 and y equals 6. So it means what? It means y equals y. So it means here, okay, here. X squared minus 3 equals 6, right? Here x squared minus 9 equals 0, or x plus 3 if we factorize to be like this. So x equals minus 3 or x equals 3. So the limit is from minus 3 to 3. Minus 3, 3. Okay, so the upper one is 6, y equals 6, so 6 minus x squared minus 3 dx, right? And then if we simplify again, it will be 6 plus 3 minus x squared, right, dx. So here it will be what here? Minus 3 to 3, 9 minus x squared dx. Alright, and then we calculate definite integration. So it will be 9x minus x cubed over 3 minus 3, 3, like this. We substitute with 3 first, so 9 times 3 minus 3 cubed over 3 minus 9 minus times minus 3 minus 3 cubed over 3, like this. So you know that one is 27 minus 9 minus that one is minus 27. That one will be positive here, will be negative 3 cube. It will be negative 27, but it's negative positive 27 over 3. How many? 27 over it is 9, yeah. Okay, 9. So it will be that one 18, right? It's 18 minus that one should be this, since that one is 9, so negative 18. So 18 plus 18, so it will be 36. So this area, the area is 36 unit square. Okay, it's long, yeah. Let's see the answer then. Which one? This one. Okay, so it's 36, question number 4, right? So it's true. All right, this is how we can find, yeah, the area bound by curve and a line, or by two curves, right? So inshallah it will be easier for you when watching this. Okay, see you in the next video.